Hey guys, this video is brought to you by codeforinterview.com, and this is part of a series of interviews on Hadoop and other technologies. You can find more interviews on codeforinterview.com. So let's get started with the Hive questions. So can you define what is Hive?
Sure. Hive initially started as a abstraction of the MapReduce, which gives a SQL-like query language to access and manipulate data.
Can you tell us like how Hive operates over MR MapReduce?
Sure. So because the interaction or the interface with Hive is more related to SQL-like language, the four structures that we have, like filter or projection um, and joins, are all done using the underlying MapReduce code. For example, a simple filter query like select star from a table where a key equal to some value would be translated into a mapper only job which reads the data and filters each event or each filters the data line by line and looks for that particular um, field and either sends it across or drops it. So similarly, a more um, complex query in Hive would be a join, which uses multiple structures, as in files like. Hmm.
Can we, instead of using like MR, can we use Spark in Hive as execution engine?
Yes, we can. So Spark provides us with Hive context, which allows us to do that.
Okay. So can you tell me about like what are the different meta stores Hive has?
So the major component of Hive is the metastore, which stores the schema of the different data sets, which is analogous to. Okay, if I can take the analogy of the Hive to any RDBMS, we have databases and tables and columns and the associated data types of each column. So all this information is stored in a repository which can be a local or a single user based repository, which is a Derby database, and that is supposed to be accessed only locally. And the other location for this metastore could be a external location, which could be either on the same machine or a different node. Um, and this repository could be any RDBMS like MySQL or Postgres. And the other location is the remote location for the metastore, which is introduced because of the security issues that pop up due to an external metastore because of the availability of the node address and the password to access to be accessible by any user.
So what will happen if the meta store fails, like the DB goes down?
So if the metastore, so this would be an analogy of what a name node is to a Hadoop cluster. So all the schema information, because it's stored in the name node, if a name node goes down, the data is useless. Similarly, if the metastore itself is unavailable, we cannot query the datasets using Hive.
Can you tell us like more about Edge catalog?
Sure. Um, So Edge catalog is an interface for the clients to use the metadata stored in a metastore. For example, there are n clients other than Hive clients that wants to or that can make use of this metadata information. For example, Pig is one client. So for example, if you are creating the metadata of one particular data set and storing it in Edge catalog, the same Edge catalog could be used as an interface by Pig to get the schema information of that data set.
Okay. Where does Hive store the actual physical files?
So, okay, so Hive, when you store data in a table, so each table is associated with a location on HDFS. If it's a internal table, it's stored in the default Hive warehouse location. And if it's an external table, the data is stored in the location specified by that external table during the creation time.
Can I configure the default internal, and where is it default stored?
So,
Do you know the location?
yeah, so by default, the Hive warehouse is located at user Hive warehouse and followed by the database name, followed by the table name. Um, so that is where all the internal tables store the data in. If it is an external table, you will need to provide any custom location on HDFS during the creation of the external table, and any data that you store in the external table will be put in that location.
But how do I change the internal table location?
So the internal table location is defined in Hive site XML as a property, and you can change that property at that and restart the Hive service, and it will get into effect.
Okay. What is partitioning?
So partitioning is a concept that was introduced in Hive to optimize the queries. For example, if we have all the data in one location and our queries only look at a part of the data, then we are wasting a lot of resources going through the complete data set that is available. And the better way is to create partitions of this data, which essentially means we look at the schema of the table, and then we look at the query that we want to optimize and partition based on that.
Can you give one example?
Sure. So if we have daily user data coming in, and we are dropping that data into one particular directory and running queries on top of that. So if we do not have any partitioning defined on that particular table, and our query reads select star from user info, where date equal to today, or date equal to so and so. So that would kick off a job that will read all the data from the beginning of time and filter based on this key value, which is the date. The optimization that we do here is that during the creation of this table, we create a partitioned table, and we specify the partition column to be the date, so that whenever the new data comes in, new data in the sense the data coming in each day is put in a new directory in the location, in the source location.
What is the name of the directory? Do you know? Like how do
Yes.
you create?
For example, in this table that we have been discussing about for user info, if the partitioning column we have defined is date, then and if it's an internal table, the path would be user Hive warehouse and the database name, which is suffixed with .db, and the table name user info. And within that user info directory, there will be a directory which is named as date equal to and the actual value for that particular day, and then the subsequent files are dumped into that directory. So if data for different days are dumped into the same table, you will find that over a period of time, you will have n directories, and the name of the directories will be the column name, that is the date, equals the actual value for that particular day.
What is bucketing then?
Bucketing is a further is an optimization provided by Hive, which is more useful in terms of joins. So bucketing uses hashing. So at the creation of the table, we specify the field names on which we want to bucket the incoming data in. So if we specify for the date, we want to bucket based on the user state. So state in the sense the actual location of that user. So within this particular partition, which is based on the date, we can further divide it into chunks of buckets where each bucket would be associated with a specific state or specific value.
Okay. Can you tell me the difference between what's like pig and hive?
Sure. So I can start off with the location, I mean, the usage of pig and hive. Pig is used more like a data flow language that we can manipulate the data and use it for programming, whereas hive are essentially used by clients, which does reporting and ETL-like operations. Um, and I think,
Say there is a job which is running like really slow, and that's a hive job. How would you debug? Like, how would you go around that?
so this would be a very open-ended question. So we first start off if it's a known job that has been scheduled over time, and we see that it's progressively getting slower.
Or if say very first time it's slow, then what would you do?
Okay, so we first look at the amount, or we look at the data and see how the number of mappers and the number of or the amount of resources which are being allocated to this particular job by default. And then we start off at that point, and by default, the number of mappers that are allocated for a job depends on the data size. Um, and if we see a reason to increase the number of reducers on our job, we can specify a property in our job to increase the number of reducers, and it will in turn help us to parallelize the operation. And we should also be looking at, so we have discussed a couple of optimization techniques in terms of partitioning and bucketing. We should also look at the table structure and the query that we are running to see if any of these optimization techniques could be used to make sure that our query runs faster. And also, oftentimes we have default values set on the cluster in terms of the amount of memory that is allocated to an individual mapper and a reducer in terms of heap space and the memory. And we can tweak those values in order to further tune the job.
Yeah, okay. That's all for today for the Hive questions. So if you have any more questions, then please like leave it in the comments, and please do visit Code for Interview for more questions and more videos. Thank you.